Hello, and welcome to this second video on SQL with PostgreSQL. In the last video, I showed you how to run a 17 version PostgreSQL. So what I want you to do is you go to postgresql.org and then hit documentation, and you will be brought to this page. And I want you to download the PDF of the PostgreSQL version which you are running. Most probably you would be running something like 16 or 17. If you have an older version, you can download it, an older version, and I'm here. So this is chapter 8, data types, and we will go through this in a bit. Then you will need to see whether your Docker container is running or not. So you can see that status is exited 2 hours ago. So we need to start it, docker start Postgres container, and then we see the status. Yep, it is up and the ports are mapped. We launch our pgadmin. I had configured it in the last video, and then it will ask for the password. The password is ABCD. For you, it might be different. So now you can see that we have one database, Postgres, but we want to have another database, so we'll create a database. We call it something like test. Don't worry about other parameters. Let the owner be Postgres. Usually, you would like to configure a role which is not Postgres to create the database, or maybe create the database as Postgres and then give the table ownership, or at least the privilege of select, insert, update, delete, and so on to a normal user. But those are advanced things a bit. So let's first get up and running with the basics. So we create a database test. So we have our database test. So this is the Postgres command which was executed to run this, to create the database test. And now what we will do is we'll create a table first. Okay. So we have our query tool. Yep. So we are connected to test. And if you want to use Docker, then we can run Docker exec -it, and we can give here the name of the container, and you can say bin bash. And here we change to user Postgres, and then we run. Now the way to create database is one by what we did from pg admin. The other way is you can simply say create db test1, and it will create a database test1, which you can see here. If I say refresh, you see test1 is here, and you can connect to test1 as well. The other way would be you simply do PSQL, and you can say create database test2, and test2 would be created. We can refresh this, and we have test2 as well. So the SQL, which you see, it does many things. It creates database. Owner is Postgres, which is by default Postgres. Uh, that is the user with which you are running the command. We have encoding UTF-8. We have collate and C-type as n_US UTF-8. These are encodings of UTF-8. Locale provider is libc. Table space is PG default. Connection limit is unlimited. Is template false. So by default, these values are good enough. You don't need to worry about this. The one thing which you can probably change is the connection limit when you try to create the uh, database, but more on that we will see later. So before we can continue, we want to create a table. Now, what is a table in SQL database? So I assume that we have worked with something like Excel. or you have seen a table. Table is nothing but rows and columns. In RDBMS, every row is unique or supposed to be unique. Duplicate rows should not be there because duplicate rows are redundant. One of the ways to make rows unique is by assigning a primary key, unique primary key to each row. That primary key is typically called ID or PK for primary key. Other columns are the what we need with the data. So for example, let's say we are creating a library management system, for example. So in the library, we will have a table called books. Now, primary key is of type big serial, okay? And the way to make it primary key is, we call it primary key. Big serial means it increases automatically as data is inserted. So for example, this is the big serial. It is auto-incrementing 8-byte integer. The other popular data type for primary key is UUID. Okay, UIDs are, I believe, 128 bit. Okay, while this would be 64 bit. So UID are quite large. Now there are two types of UIDs, UID4 and UID1. UID1 is guaranteed to be unique, but it includes the MAC address information of the current computer into the ID. UID4 are purely random. It doesn't rely on MAC OS, but there is very little chance that it can collide. But there is no such collision in UID1. Still, people prefer UID4 because the chance is so small that a meteor falling to Earth has much higher probability than UID4 clashing. So to start with, we will have big serials. So we have ID. Now in the library, the most important thing are books. So we'll say the table name is books. We will have name. A book can have a large name. Okay, it can be quite long. So we assume that a book is no more than 256 characters long. Okay, so we call the name varchar 256. Now varchar is here. It is character varying, variable length character string. So the name can be less than 256, but we assume that uh, its name is less than 256. Now, book can have multiple authors. There can be one author, there can be two authors, there can be 3, 4, 5, 6. I don't know. If you there's a book called Beautiful Code, in which more than 50 authors have contributed. But for now, we will have author one, author one. The name of author one will be varchar, let's say 128 characters. There is rarely an author whose name will be longer than 128 characters. We say author 2, varchar 128, and let's say we have author 3, varchar 256. We have author 4, and we have varchar 128. So we have, for now, we will have 4 authors. Okay. I will show that how we can have any number of authors later on, but for now, let's plug the authors right here. Then we will have something called ISBN number. So ISBN number is basically, it consists of digits only, but still you will put that in the varchar category. I don't know how many are there, but usually they are not more than 32 characters. So we'll call it ISBN. And then we will have price of the book. So price is usually an integer of a book. I have yet to see a book whose price is a floating point number. So the price can fit in 4 bytes. So we will use integer. We will use plain int object for this. We don't have unsigned integer here. I don't think that it has unsigned integer. It is signed integer. So we have to be careful that we don't insert negative numbers. So I think to start with, this is enough. And the other is copies, how many copies we have, okay? So we make this also an integer. All right. So this is our table and we call it create table. Let's see if it works, okay? Do we have the closing parenthesis? Yes, we have the closing parenthesis. So the way to execute this is you select table test on which you want to run this. You don't have to select it. This query tool is connected to a particular database, which is signified here test/postgres @localhost. I cannot increase the font here. Let me increase the font. I'm not sure if it will allow me zoom in. Yep, view, zoom in. Okay. We don't want Sketchpad right now. So we select this and then we click this execute script. The shortcut key is F5. So we run this and we have a problem here. We mistyped varchar. So we'll fix that. And then we say run again. Our query has run successfully. Now we could copy this and we can paste this here also. So here we are connected to database Postgres as signified by prompt. To connect to test database, we can say \c test. So now we are connected to test database. Now if you see the DT, you see in the public schema, we have books and its type is table. Okay. And owner is Postgres. We don't worry about schema name right now or the owner. We will cover this. The key part for us is books. And if we try to see, we can say \DT plus. So it will show us more details about it. Okay. Now we have this table books. Now if we try to find items from this books, that is done by select star from books. We see our fields are here in the order in which we had declared in the table, and there is no rows. There are no rows. So for now we drop this table. Drop means delete the table. Drop table books. Okay. So what I was trying to show you is that we can take the same SQL and we paste it here. That will also create the table. So if you see DT now, we have the books table again. If we drop the table, then you see there are no relations. So we create the table again and we see DT, we have books. Okay. So big serial, varchar, and integer are 3 types we have used. There are many types mentioned here in chapter 8. Okay. And you can create your own type also, but that is something we'll see later. So data types are here. So these are the types. Then we have numeric types. We have arbitrary precision types and so on. There are lots of types here. You can see this is huge number of types which is given here and the details of those. We will go through those slowly one by one. For now, we are not going to use all of them, so we constrain ourselves to this. So our user is varchar, big serial, and int. So we have now, if you expand this test and schemas and public, in the public you go to tables. So we have books And books has these many columns. 9 columns are here. So we can count the number of columns: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, the second thing is that we need to have some data in the books. Okay. So the way to insert data is, command is called insert into table name. So our table name is books. And how do we insert is, we specify the column name. That is the name of the book. And we have author 1. We will have only one author, okay? And for example, I don't know the ISBN number, but we will fill in something ISBN, okay? Now be careful here. This name is a key, I mean reserved keyword. So we will call it book name. We will rename it. Okay, we will call it book name. Okay, so how we can change the column book is by calling alter table books, alter column name, rename to book underscore name, and then we select this and run this. Okay, alter column. So you see, this being a keyword is causing problems. So we quote it in double quotes so that we don't have problem. Alter table, alter column, rename to. So there is an error here. Okay, my query is not correct. Rename to is correct function for Postgres. So we say rename to. We should have something. Alter column, rename to. It is correct. Alter column, rename to. There will be more. Control F, alter table, alter column, alter table, alter column, and then we have to look for rename to. Anyway, so okay, this should have worked. Let me see. Alter table, books, alter column, name, rename to book underscore name. Okay. Let me quickly Google alter column, rename to Postgres. Alter column, rename column to rename. Okay, this is one word back. Rename column next to book name. Now we run this. F5. Oops, F5, and it worked. So now you see here, if you refresh this, then we have our name column has become book name. So we have now, we don't need this. Minus. The comment is in the, if a line, leading line has minus, then it is a comment. Okay. So ISBN was there, and we had book name, book underscore name. ISBN, we will say price, and we say copies. So whatever columns you want to insert, that should be mentioned here, and then followed by that values. So we put values. So book name would be, let's say, the art of computer programming. and author one would be Donald E. Nutt. Let's keep it simple so that our querying is simple. ISBN we say 100 or 1000, and price is we say $40, and we suppose this is price is not varchar 40. Varchar will be in double quotes and integers without quotes. And let's say our library has 10 copies. Okay. So we select this and we say F5. So it says that we have an error. Most probably it will be in single quote. Yep. Yeah, it should be in single quote. Double quotes do not work here. So we change this 1000 also to single quote. All right. So we have our query running successfully. Okay. Now we have our columns here. We have inserted here. Now what we can do is we can select star from books. We can call it select query. So you see that our fields have come. So primary key is one, book name is Art of Computer Programming, author one is not, author 2, 3, 4 are null, ISBN is 1000, price is 40, topic is 10. All right. So this is how you create a table, change name of a column, insert into the table, and you select from books. Okay. If you are inserting all the columns, then you can avoid this. You don't need this. Okay. But the insertion should be in order and the data type should be proper in any way. So select star is a very bad idea. You should probably never do select star. The reason is that if you do a select star, then the database has to enumerate the column names. So an alternate way is that you specify column name, select book name from books. Okay. So we take this and we run. So our book name is The Art of Computer Programming. Suppose if we also want author one, then we can say author one and we execute this. Semicolon is mandatory when you are running from command line, but it is not mandatory here. If you run this, oops, it is running everything. So you select this and run this. The PG admin will send the semicolon. But in general, if you are running from command prompt, say if you say select star from books, if you run this, you will get no output. You have to terminate with semicolon and then you get the output. So make sure that you select. So the 4 columns which we have inserted, or 5 columns, can be selected like ISBN, price, copies. We can select like this and then we run this. So we have what we need here in 5 columns. Okay. Now we insert another book. We will call it Introduction to Algorithms. And we will insert more authors this time, author 2. And the first author we will name Rivest, and the second author we will name Shamir. We can fill all 4 authors, but we don't care. We will say ISBN is 1001, price is say $50, and we have 40 copies of this book. So we run this. Now, if we do select star, you will have 2 rows. Now the primary key is different. This column is basically the output column. This is primary key 1, 2, and we have authors and price and so on. And if we select books, the author 1 only, then we have this information. Okay. Now this is the basic selection. what if we want to find the books whose price is $40? Okay, so we can say select, uh, we can repeat this query here and we put it here. And here we say where price is equal to 40 or maybe less than 40, less than is equal to 40. Okay, for now we'll keep it 40. I'm not sure if less than is equal to correct in SQL terminology, but let's see. Yep, it works. So if you want to find the books whose price is less than is equal to 40, and then we select from table books and we have columns, then we have this output. But there is a problem here. Okay, what is the problem here is, ideally you should also select ID, the primary key. So the problem which we are having in this query is, when a table is created, the primary key has an index, a unique index. What that means is the values in here 1, 2, 3, 4, 5, 6 are taken from the table, and a B plus tree is created in memory. The entire table may not be in memory, but the primary key will always be in memory if there is enough memory. Okay, database will always put the keys in memory. The index is called primary key index. Now similarly, since we are using price as the where clause item, we should have an index on price. Okay, so what we can do is we can say create index price underscore idx on books references books. I'm not sure if this is correct. I don't deal with SQL every day. So let's see, we try to create this index. Okay. Okay. We simply say this, I believe. All right. Yes. So now we have our index created. Okay. And that index is called price index. Let's see if we have our indexes properly. We have books, we have columns, and if we look at indexes, we have our price index created here. Now, this you may not experience in this small example, but suppose your table has 10 million or 100 million rows, or maybe more. Then this query will become very slow if you don't create this index. So whatever is in the where clause, there should be an index. Okay. Now suppose that we by mistake have put the price as $40, which is more than what is the price of the book. The price is actually $30. Now we want to change it. So there are two ways to do it. What we can do is, the best way is update books set price is equal to, price is 30, where ID is equal to 1. That is our primary key of this. Okay, and we run this. And then if we do a select, we'll see that the price is updated to 30. Okay, so this is how you update the price. So you can set multiple columns or one column, that does not matter. But the idea is we have update, we set the books and our price is this. Okay. Now assume that we have made an entire entry wrong. Okay. For example, this entry, introduction to algorithms, and we want to delete it. Okay. Then we can say delete from books where ID is equal to 2. Okay, and we run this, and then we run the select one. Now you see We don't have, ID2 is gone. Okay, so this is a delete. Now, suppose if we want to insert this again, we can take this and we run this. Now, if we select again, then you will see something different. Now the primary key is 3. The reason is, for a big serial, uh, the Postgres database creates a sequence, and whenever a row is inserted, the sequence is incremented. Okay, but if a row is deleted, that sequence is not decreased. Okay, it will stay there. So when the second row was in when the second row was input, it created the second row, and when deleted, the sequence remained at 2. I will show you the sequence probably in day after tomorrow's video, how the sequence is there. If you want to see right now, you can see that there is a sequence here, books ID sequence. This is what I'm talking about. Okay. So if you want to see, you can see its property. Definition is there, current value is 3, increment 1, start 1, minimum 1, maximum this, and so on. Okay. So this sequence was 2 when it was deleted, and when we inserted for a second time, it increased to 3. The reason is why it was not decreased is that suppose you have lots of rows and you delete somewhere in between, maybe 2, 3, 5 rows, you delete something, then the sequence cannot go, and it has to scan the table linearly to find which rows are deleted, and that is very inefficient. So it just skips those. Those are gone. We don't have those in the table anymore. The primary key 2 now will never occur in this table. Once you delete that primary key, it is gone forever. Okay, that primary key in case of big serial will never again come into the table unless you entirely cover the range of big serial and then you rotate back to your value. But that is another mess. Okay, we won't go that far. All right. So what I have shown you is insert, select, update, and delete, and create table. This is the very core of SQL and tables. Rest assured that 90% of your life will rotate around these commands. I have also shown alter, and we have create index, and so on. So I'll stop here, and we will see more of this in the next video. So what we can do is we can save this SQL. Okay, we save this file, and so that we can reuse this in the next video. Okay, we call it pg.sql. All right. So I'll see you in the next video. I hope that you have enjoyed this video, and I was able to give you some useful information. Thanks a lot for watching. Happy programming.